Assalamu alaikum. My name is Malik Siraj, and this is Data Communication Network course. In today's class, we are going to talk about network layer, which is chapter 4 of your book, and that is computer networking or top-down approach. So the goals of this chapter is to understand the principle behind the network layer. This chapter revolves around the network layer, and we talked about network layer service models, forwarding versus routing, how router works, routing part selection, broadcast and multicast, and many different things. So these are the outline of this chapter: introduction, virtual circuits, what is inside router, internet protocol, IP, routing algorithms, routing in the internet, and broadcast and multicast routing. We talk about all of them one by one. So let's start with the introduction of this chapter. Network layer is network layer actually transports the segments. Segments is message plus header of the transport layer is called a segment. Network layer actually transports that segment. It is the layer that is lower the transport layer. It transports the segment from sending to receiving host. On sending side, encapsulates the segments into datagram. Okay, so once it encapsulates the segments into and add its it takes the segment and add its header, then that becomes a datagram. On receiving side, delivers the segment to the transport layer. It takes the segment from the transport layer on the sending side, and on the receiving side, it delivers the segment to the transport layer. Network layer protocols in every host router. As we talked about in transport layer works on the end systems, sender and receiver, whereas in case of network layer, it works on every host and router. Router examines the header fields in all IP datagram passing through it. So we are saying now that this is the TCP/IP model, physical layer, data link, network, transport, and application. This layer is implemented on end systems and also on the intermediate system. If this node is sending a data, so it creates a traffic. So we are only concerned right now. We are only concerned about the network layer. So we only show a header of a network layer in this case, and then it sends up data on the router, which opens a packet at the network layer, decides the packet based on the IP addresses, and then forward the packet to the next hop, and it ultimately reaches to the destination. So the two key functions of this layer are forwarding and routing. Okay, forwarding is moving a packet from router's input to the router output. Okay, so once a packet arrives to the in routers, any port of a router, so that router actually look up the routing table and find out the destination of the packet from that table. So if it find out that it needs to send that packet to port 3, so it forward that packet, it matches the header of a packet from the table, routing table or forwarding table. It matches the header of a packet from the forwarding table and then passes the packet to the output port. So this is what is forwarding is. So whereas in case of a routing determines route taken by a packet from source to destination. Okay, routing is the whole path that a packet takes once you are sending a packet from source to destination, and that is determined by the routing algorithm. So routing and analogy, you can say routing is the process of planning the trip from source to destination. Complete trip is planned by the router, whereas forwarding is the process of getting through in a single interchange. So in every choke where you go, so you are on that choke, you are actually forwarding yourself from one link to another link. So we will talk about that. So let's say this is my network, and in that network there are multiple routers that are there. So this is the packet that is coming in. Now let's open this and what is inside this router broadly. So this router contains two things. One is called a routing algorithm. Okay, one is called a routing algorithms and other is called a forwarding table. Okay, routing algorithm is end-to-end path through the network, whereas a forwarding is a local forwarding at this router. So once this packet arrives, let's assume that this is the header of the packet. 011. So once this packet arrive, what forwarding do? It will check this packet header and compares its header value to its local forwarding table. This is the local forwarding table, and find out that this is the header value that matches to 011, and it says that when it matches to this header value, it needs to forward that packet to output link number 2. So it is sending this packet to this link, which is output link number 2. How this table came into this table is made by this routing algorithm. Once there's no routing algorithm actually fills this table and identifies that which header values goes to which output link, so that ultimately packet arrives at the destination, or packet reaches at the destination. There are two types of services that are used at the at the network layer, which is a virtual circuits and a datagram. Similar to a connection-oriented transport and connectionless transport, there exists a virtual circuits, which is a connection-oriented network provides a network layer connection service. It's a connection-oriented service, but nowadays it is not being used. That is becoming an obsolete. And there is another service, which is a datagram. This is a connectionless service. A network layer provides a network layer connectionless service. There are two types of services: datagram services and virtual circuits. Virtual circuits are getting obsolete. Datagram service is getting popular. Nowadays, you will find 95%, which is a datagram services or more. So virtual circuits actually establishes a connection at the network layer. How it is going to establish a connection, we'll talk about. Similar to TCP UDP connection, where service is end-to-end, host to host, no choice, and intervention in the network. So let's talk about in detail about the virtual circuits. Virtual circuits is source to destination part behave just like a telephone circuit. Resources are reserved, whereas in case of connectionless services, there are no resources that are reserved. Whereas in case of virtual circuits, there are resources that are reserved for the call. So it behaves much like a telephony circuits performance-wise. Network action along the source to destination. So it requires a call setup, tear down for each call before data flow. So virtual circuit in order to send our data, so you need to establish a call and send our data, and once data is finished, you need to tear down that connection. Each packet carries a virtual circuit identifier, and that is different from destination host address. That has nothing to do with the destination host address. How it works, we will talk about. Every router on the source destination path maintains states for each passing connection. Every router maintains a state. We will talk about. Link router resources, bandwidth or buffer may be allocated in the virtual case. So once I'm making a call, so it might possible my router has no resources. So I have promised, a service provider promised its user that you always have a 99.99% you have a connectivity, but it is if it is making a call, there is no connectivity because the resources are not there. So they initially establish a virtual circuit to resolve such type of issues which are there in case of telephony. Resources are reserved, so users get what they promised. But now in Datagram, there's no need for that because of high bandwidth and high throughput and many other protocols that are doing such things. So let's again talk in depth of virtual circuits, how virtual circuits works. A virtual circuit consists of path, a source to destination, a path, a virtual circuit number, a number that is independent of the destination IPs, and it is a number which is one for each link along the path, and entries in the forwarder. You need to have a forwarding table that contains virtual circuit numbers, so that once a packet receives, it find out the virtual circuit number and forward that packet to the output lines. Packet belonging to the virtual circuit carries virtual circuit number. Virtual circuit number can be exchanged on each link. So let's talk about this thing. So let's assume that this is my network. In this network, there are two hosts. There are two end systems which are sending, which have established a virtual circuits. So let's talk about this router and see the entries of virtual circuit of this router. This is the forwarding table of virtual circuit for this router. So this forwarding table says that this is the incoming interface. It has 4 columns: incoming interface, incoming virtual circuit number, outgoing interface, outgoing virtual circuit number. Okay. So it says that incoming interface is 1, incoming interface is 1, and incoming virtual circuit number is 12. So it says that if on this router incoming interface is 1, packet is coming from this interface and has a virtual circuit number of 12, then it needs to forward that packet, that datagram, on the outgoing interface of 3, and it changes the virtual circuit number to 22. So what it is doing is this router is identifying, matching this incoming virtual circuit number and interface number from its table, and then forward that thing to the output link and updating the virtual circuit number of that packet. And these are the different other entries of this router, virtual circuit entries of this router. So it says that if packet is coming from interface 2 and has a virtual circuit number of 63, then it needs to send that packet on outgoing interface 1 and virtual circuit number 18, and so on. Virtual circuit signaling, how it is going to identify that which incoming virtual circuit number it uses. So we already talked about that. You need to establish a connection. So initially initiate a call, incoming call, and then the end host actually replies to that with an accept call, and then when calls is established, so it exchanges the data. During the establishment of a call, they identify that virtual circuit number on each of the link that they can use. So it is used in ATM, Frameless, X25, not used in today's internet. So this is the example of a virtual circuit. It tells you how you are going to choose the virtual circuit numbers. So it assumes that this is my sender, which is sending a data to this receiver. So they needed to they adopted this path to send the data. So initially A is establishing a connection. Okay, it's called initiation. A send a packet, and in that packet it tells that this router R1 that it needs to forward a packet. It needs to establish a virtual circuit between A and B. Okay, so it sends a packet. So what it is doing is this router receives a packet on port 1. Okay, this router identifies that it needs to forward a packet to a destination B, so that in order to forward a packet to a destination B, it needs to forward a packet to port 3. So it added that value, and then this router R1 created a label identified locally that it can use a label 14 for this. Okay, so it added a label over there and sent a packet to this router and telling that A needs to establish a connection to virtual circuit to B. So once this packet received at router R3, it says that this packet is coming on port number 1, input port 1, and this packet needs to be sent to destination B. So it find out that in order to reach at the destination B, it needs to forward that packet to port 3. So it needs to forward a packet to port 3, and this router again uses a virtual circuit number of 66 that it and we will talk about that virtual circuit number too. So it tried that virtual circuit number. It's a random number that it chooses. It sends the packet to R4. The R4 do the same. It says that packet is coming from input port 1. It needs to forward to packet to port B, so it says that it needs to forward that to port number 4, and it chooses a random virtual circuit number, which is 22. Now this packet received to destination B, and then it in order to accept a call, so it sends a packet reply. In that reply, it is saying that if you want to establish a connection with me, that connection, if A wants to establish a connection to me, if A wants to establish a connection with me, then all the packets that are coming on that virtual circuit number, it tells this router R4 that you should use a virtual circuit identifier which is 77. Once there is a virtual circuit identifier 77, then I assume that this packet is coming from A. So it sent that packet to this thing, Then this router update its forwarding table with the outgoing label 77 port this, and this send a packet to this router that if you want to establish a connection with B, then you need to send a packet with the incoming virtual circuit number of 22 to me. Okay, so this is taken from there. Similarly, this router tells this router R1s that if you want to establish a connection, you need to use a virtual circuit number 66, and this router tells this A that if you want to establish a connection, you should use a virtual circuit number which is 14, and that we are using as a link. So this is how calls is established. Now once A send a data and it says that this is a data from A to B, it is enclosed in a packet with a virtual circuit number 40, and then all the routing is performed on the basis of virtual circuit number. Once this packet is received at router R1, it says that this packet is coming from interface number 1 and has a virtual circuit number of 14, so it consults its table and says that it needs to send that packet to port number 3 with the virtual circuit number 66. So it sends that packet to port number 3 and update the virtual circuit number to 66. Now once this receives a packet, it says that if incoming packet is coming from port number 1 with the virtual circuit number 66, then it needs to forward that packet to port 3 with a virtual circuit number 22. Similarly, this will also do, and once it says that it receives a packet with port 1 and in virtual circuit number 22, it send a packet on port 4 with the virtual circuit number 77. And once it receives this packet, it says that this is a packet which is coming from A. And based on the virtual circuit number, each of the router can reserve resources for that circuit, so that the promised resources are given to the end systems. So datagram network. In case of a datagram network, there is no call setup at the network layer. That is, there is no call setup at the router. So now let's talk about datagram networks. In datagram networks, there is no call setup at the network layer. Routers no state. Routers no maintain any states. Packet forwarded using a destination host address. So this is a network, and these are the packets that are coming. So once they arrive, this router opens the packet and examines the header and find out the destination host address, and then based on the destination address, it forwards the packet to required output ports. So this is the send datagram, and this is the receive datagram. This is the packet that arrives to this router. So this router opens a packet, and then this is the forwarding table that has the range of addresses and then output links. So this router opens the packet and then find out a match. Let's assume that this is the match, so it forward a packet to port number 2. Since we know that IPv4 and IPv4, IP address is a 32-bit number. So it means that if we are going to add individual IP addresses in this table, there are 4 billion entries in the entries in the forwarding table. So it is not possible to actually add so many IP addresses in the IP table in the forwarding table, and then do a match once each packet arrives. So what we can do is we can define the range of addresses and their output interfaces. So it says that instead of having the addresses match addresses like that, we have a range of addresses. It says that from this IP address to this IP address, this is an IPv4 address. So this IPv4 address has 32 bits, 8 bits, 8 bits, and 8 bits. So total it becomes 32 bits. So it says that once a packet arrives and the destination addresses is in between these two IP addresses in this range, so it sends the packet to range output link to 0. If it is in this range, it send a packet to this output link. If it is in this range, it send a packet to this link, and otherwise it send a packet to this. But what happens if the ranges do not divide so nicely? Range divide new, so this is the packet. So the router forwards the packet based upon the longest prefix match, because those ranges can overlap each other. So once they overlap, how the router going to decide which packet it forwards to which interface. So let's try to understand what is longest prefix match based on that, so that we can understand how router do the forwarding. So in longest prefix match, when looking for a forwarding table entry for a given destination address, use longest prefix that matches the destination address. So this is the address range. In this address range, this is a 32-bit number. So this is an 8-bit number, 8-bit number, 8-bit number, and 8-bit number. So this is a 32-bit number. In this 32-bit number, in these three 32-bit numbers, these two octets are same, which is 200.23, and these two octets are different in these three ranges. Okay, so let's talk about it. So in order to convert it into a readable IP form, so you need to convert this 32-bit number into decimal, which is 200, then dot, you need to convert this number into decimal, which is 23, and then dot. So if it is a complete IP, you need to convert this number, and then if this is a complete IP, you need to convert this number. So in this scenario, it is not a complete number, it's a subnet, it's a network which shows in order to convert it into a subnet network. So you need to find out what this is going to represent. It is 1 2 4 8 16. 16 bit is 1, 16 32 64 128. 16 bit is 1. So it is 16 dot, this is 0, and slash is the subnet part. It says that all those bits which are don't care represent the subnet, which is used as an IP address in this range. So it is 1 2 3 8 plus 8 9 10 11. So it is 11. So here I put 11. In order to see more detail, so this is let's do another example. So this is 200.23 dot, this is complete 8-bit number. So if I read this number, 1 2 4 8 16, 16 plus 8 is 24, so it is 20.24 dot 0 slash, and this is 8-bit. sorry, there's an issue, there's a minor issue over there. It is not 11 actually. Okay, it is actually we write this number as there's a typo over there, so it is actually it was actually written 11, so I just rectified it. It is actually 21, which is 32 minus 11. These are the 11 bits, 8 19 11. So you need to minus the total number of bits minus these bits, actually that represents the network part. So it is 21 24 and 21. So in this example, let's assume that if this is the destination address that is coming on a router that has this forwarding table, so if this is coming, so we know that these two octets are same in this, and rest of these two, which is 200.23. If you look into this remaining part, so it matches 00010. 00010, it matches all of them. 00010, it only matches to the first entry 00010, so it will go to the output link 0. Now let's talk about the second one. So now if you look into the second one, actually it matches the two of those entries, this one, this entry, and this entry. So it has this number which is same in both of them. So this number is same in both of these entries. But if you look for the longest prefix match, so the longest prefix match, it matches this value 000. So it has a 000, so it matches that value, so it goes to the output link number 1. So this is how longest prefix match works. So now let's move on and talk about what is inside a router in more detail. So router architecture, there are two key router functions. Run routing algorithms. Router actually runs routing algorithms, and there's another thing which is it is doing forwarding. Okay, if we look into the router, so these are the inputs of the router. Okay, these are the outputs of the router. This is the switching fabric. ठीक है. This is the switching fabric, high speed switching fabric, which is switching which is moving the data from any of those input ports to any of the port which is output port. Okay, so this router is divided, the router is divided and has two parts. One is called a routing and other is called a forwarding plane. Okay, in the routing plane you have routing and management. And there are multiple algorithms that perform routing. We will talk about those algorithms too later on in this, maybe in this lecture or in the next lecture. And this is the forwarding part, which forwards the data. So if you look into this thing, so actually whenever the packet arrives at the port, which is the Ethernet port that you are familiar with, RJ45 connector. So whenever packet arrives at that port, so packet needs to store at some place. So this packet needs to store at some place. So packet first of all stores. This is a line termination. ठीक है. So packet is coming and line termination, link layer protocol है, and then forwarding and lookup table है और queuing perform हो रही है. जब भी पैकेट आ रहा है तो मेरे पास राउटर के अंदर जो उसका आर्किटेक्चर होता है, मैं पिछली फिगर में आता हूँ. बेसिकली इसके पास जो भी इनपुट पोर्ट्स होती है, हर इनपुट पोर्ट के साथ आपके पास ना इनपुट क्यूज़ अटैच होती हैं. जो भी पैकेट आता है वो इनपुट क्यूज़ में जाएगा और वेट करेगा. जैसी राउटर प्रोसेसर इज फ्री, सो इट पिक्स द पैकेट and open the packet and matches its header with its table. If a match found, it forwards the packet to the respective destination. So if there's a line termination, there's a link layer protocol, data link protocol, and then queuing plus forwarding lookup table. So अगर मैं स्पेसिफिकली फिगर में आऊँ तो it says कि मेरे पास जो राउटिंग प्रोसेसर है या राउटिंग एल्गोरिदम्स हैं, वो क्या कर रहे हैं, वो जब राउटिंग कंप्यूट करते हैं तो राउटिंग कंप्यूट करने के बाद ये जो टेबल्स हैं जो रेड से दिखाए जा रहे हैं, इन टेबल्स को वो अपडेट कर रहे हैं. ठीक है, इन टेबल्स को वो अपडेट कर रहे हैं, दीज टेबल्स. ठीक है, ये मैं कह रहा हूँ ये फॉरवर्डिंग टेबल है. तो जैसे ही जो भी पैकेट आएगा वो क्यू में पड़ा होगा. जब राउटर उसको उठाएगा, उसको मैच करेगा, जब भी जिस एंट्री से मैच होगा तो इट यूजेस अ स्विचिंग फैब्रिक टू डायरेक्ट दैट पैकेट टू एनी ऑफ दोज पोर्ट्स. ठीक है, वो किसी भी पोर्ट के ऊपर जो भी आउटर पोर्ट है उसके ऊपर वो फॉरवर्ड कर देगा. ठीक है, दिस स्विचिंग फैब्रिक कैन बी क्रॉस बार स्विचेस और कैन बी एनी अदर स्विचेस. सो फिजिकल बिल्ट लेवल रिसेप्शन है, डेटा लिंक लेयर जो हम लोग अगले चैप्टर में पढ़ेंगे. मेरे पास इथरनेट का वो टर्मिनेशन है. डिसेंट्रलाइज स्विचिंग, गिव डेटाग्राम डेस्टिनेशन लुकअप आउटपुट पोर्ट यूजिंग फॉरवर्डिंग टेबल इन द इनपुट पोर्ट मेमोरी. गोल इज टू कंप्लीट द इनपुट पोर्ट प्रोसेसिंग एट द लाइन स्पीड. क्यूइंग, इफ द डेटाग्राम अराइव्स फास्टर देन द फॉरवर्डिंग टेबल. अब ये जो क्यूज़ हैं ये इनपुट क्यूज़ भी हैं, आउटपुट क्यूज़ भी हैं. ये खाली इधर क्यूज़ नहीं है. इफ़ यू लुक इनटू दिस थिंग तो मेरे पास ये भी, यहाँ पे भी मेरे पास इधर भी क्यूज़ पड़ी हुई हैं, आउटपुट पोर्ट क्यूज़ है. इसका मतलब है कि मेरे पास पैकेट जब आया है तो राउटर के अंदर क्यूइंग वाले दो किस्म के आ रहे हैं, एक इनपुट क्यूज़ आ रहे हैं और एक आउटपुट क्यूज़ आ रहे हैं. ठीक है, स्विचिंग फैब्रिक. अब स्विचिंग फैब्रिक है, वो स्विचिंग फैब्रिक यहाँ तो मेरे पास मेमोरी हो सकती है, ठीक है, या बस हो सकती है, या क्रॉस बार स्विच हो सकता है. ठीक है, मेमोरी है, मेमोरी का लुकअप परफॉर्म हो रहा होगा और लुकअप से वो परफॉर्म होने के बाद वो रिस्पेक्टिव उस एड्रेस पे जा रहा होगा. क्रॉस बार स्विच बस है. At one time only one can use a bus or there is a crossbar switch जो कि यूज हो रहा होता है. First generation routers, traditional computers with switching using direct CPU control, packet copy to the system memory, speed. अब हो रहा क्या है, पैकेट आया, अब ये दिखाया जा रहा है कि मेमोरी के थ्रू कैसे कॉपी हो रहा है. पहले मेमोरी में कॉपी होगा और फिर वहाँ से वो आउटपुट बफर्स में जाएगा. अब अल्टीमेटली इसका मतलब है मेरे पास ये जो सिस्टम बस है ये 2 दफ़ा यूज़ हो रही है. ठीक है, पैकेट इससे 2 दफ़ा पास हो रहा है. स्विचिंग वाया बस, डेटाग्राम फ्रॉम द इनपुट पोर्ट मेमोरी टू द आउटपुट पोर्ट मेमोरी वाया स्टैंडर्ड बस. बस कंटेंशन, अब बस एक है, बस की वजह से कंटेंशन हो रही होगी. ठीक है, इसके ऊपर आप स्पीड बस के थ्रू आप अचीव कर सकते हैं 32 गीगाबिट पर सेकंड, जो कि सिस्को का 5600 के राउटर के अंदर जो स्विचिंग फैब्रिक लगा हुआ है वो बस मेथडोलॉजी है. ठीक है, और स्विचिंग यूजिंग इंटरकनेक्शन नेटवर्क, ओवरकम द बस बैंडविड्थ. ठीक है, बस बैंडविड्थ लिमिटेशन. और बेसिकली अगर आप देखें तो स्विच सिस्को 12000 में ये यूज़ हो रहा है और इससे आपकी ओवरऑल जो स्पीड है वो 60 gigabit per second पे जा रही है और nowadays it is moving on to more than that. आउटपुट पोर्ट में आ रहे हैं देयर इज़ अ बफरिंग रिक्वायर्ड व्हेन द डेटाग्राम अराइव्स फ्रॉम द फैब्रिक फास्टर देन द ट्रांसमिशन रेट. ठीक है, अब थिंक अबाउट नाउ पैकेट ने आउटपुट के ऊपर देयर इज़ अ ट्रांसमिशन लाइन जिसमें पैकेट ने बाहर उस ट्रांसमिशन लाइन से बाहर जाना है. ठीक है, दैट कैन बी इथरनेट, फाइबर और वायरलेस लिंक आपका यूज़ हो रहा है, कोई भी लिंक है जिससे उसने बाहर जाना. अब अगर मेरे पास डेटाग्राम ज़्यादा तेज़ी से आ रहे हैं और मेरे पास आउटपुट का ट्रांसमिशन रेट जो लिंक है वो स्लो है, तो अल्टीमेटली क्या होगा, पैकेट को बफर होगा जो कि आउटपुट क्यूज़ के बफर में होगा. स्केजुलिंग डिसिप्लिन, चूज़ अमंग द क्यूड डेटाग्राम फॉर ट्रांसफ़र. के आप देख रहे हैं कि बेसिकली कौन सी आपके पास ना कैसे ट्रांसफ़र हो रहे होंगे स्केजुलिंग से.